So on the third homework assignment, there were a couple of questions that a lot of people had problems with. And so I'm going to go ahead and just, walk you through the solution to MSL3 number 5 and also number 7. So that's what this video is going to be. So number 5 is a t-test where you have two independent samples. So the problem set up here is that there was a study that found that children who watched a cartoon with food advertising ate this many grams of crackers as compared to this many grams for another sample, that is the children who watched a cartoon without food advertising. Okay, and so we've got a sample size of 58 here, and they were both 58, and we were given standard deviations for both samples. Okay, so as you can probably tell, this spreadsheet that I gave you could get you a good way along solving this. So we've got our two samples, sample 1 and sample 2. And although I've added some formatting, this is the same as the spreadsheet that I uploaded to D2L. So I'm just going to start populating this. So just to kind of organize all of the information that I'm given. So I know that there are 58 children in each group. So I just put that in. And I see that the mean for one group was 27.4. Okay. And it was 21.1 for the other one. And your values are probably going to be a little bit different. And these are all randomized. And standard deviation for one group was 8.7, and for the other group 7.7. Okay, I think I got those lined up correctly. Okay, so all that I'm doing here when I calculate the pooled variance is just implementing this formula down here. And so if you take a look at exactly what that's doing, you'll see that this is nothing more than calculating that, which is on the slides and in your textbook. And then this test statistic here is just calculating this. So you see that it's just the difference between the two sample means divided by this thing involving the pooled variance that was previously calculated. Okay, so this is giving you these two things, so the pooled variance and the t-statistic. Now, that's only part of the battle, because we also need to figure out, well, what question are we asking here in terms of the initial hypotheses. So let's do this. Let's go ahead and take a look at what our initial hypotheses are going to be. So we're asked to assume a significance level of 5% here, and we're asked, is there evidence that the mean amount of crackers eaten was significantly higher for children who watched food ads? Okay, so anytime we're asked to investigate whether one thing is larger than another, we have a one-tail test. So if we're simply asked to say, is there a difference, then we're interested in rejection regions both to the left and to the right. But if we already have some idea of one being bigger than the other one, then we want to make sure that we're setting this up as a two-tail test. Okay, so let's think about what we're going to look for then. So and I apologize for the bad drawing here. I don't have my usual equipment here. I'm having to draw on the screen. Okay, so I've got this is going to represent the difference between my two means, right? And I just want to know if so we'll have mean number 1 be for let's see, the weights of the crackers eaten by children who watch food ads. So that will represent the ones who do see the food ads. So I'll just call that food. Okay, yeah, very, very tidy here. And so that would mean that the other average is going to indicate who did not watch those food ads. Okay, so food and not. Okay, so the question asks us, okay, well, is there evidence that the mean amount of crackers eaten was higher for children who watched the food ads. So we're interested in the alternative hypothesis that, okay, so this is H1, that mu1 is greater than mu2. Okay, so that's what we're asking, and this is going to be our alternative. So we'll set up our null as the opposite of that. Okay, so the opposite of mu1 greater than mu2 is that mu1 is less than or equal to mu2. Okay, all right, so that means that we are going to have a rejection region only to the right. We're only interested in a t statistic that winds up being very far out here to the right, because this will enable us to reject this notion that the statistic, which is x bar 1 minus x bar 2, is going to be less than or equal to 0. Okay, so let me just slightly rewrite this first hypothesis here. So this is doing a little bit of algebra, subtracting mu2 from each side, and we preserve the direction in the case of subtraction. So okay, so we're going to see if we can reject the idea that this difference is less than or equal to 0. So we're only interested in a rejection region on the right. Okay, so we're only going to have one critical value, and we're interested in the area to one side of our statistic. Okay, so let's go back and see if we can answer a few of these questions then. Okay, so so given the problem set up, what are our null and alternative hypotheses? So we've got the one corresponding to what we just figured out would be this one, right? Okay. Okay, so what is the test statistic? Okay, so figuring out the test statistic, this spreadsheet actually does calculate it right there, but you just keep in mind that what we're doing is this formula right here. All I did was just plugged in values to this formula. Okay, so we need 2 decimal places, so 4.13. All right. Okay, and what's the corresponding p-value? Okay, so once we start talking about the p-values and the critical values, we need to take into consideration whether it's a one-tailed test or a two-tailed test. Okay, and in our case, it is a one-tailed test. We have only one rejection region. Okay, and so we have it calculated for us here. But let me go ahead and construct it so that you can see how you do something like this. So we just want to know, okay, go back to this drawing here. What we want to know is we've gotten our t statistic, okay, right? And it's a positive, it's 4.13. So we wound up getting, something out here, 4.13. And what we want to know is how much area is there to the right of 4.13. I don't know if it's, it's going to be to the right here like this. Okay, so if we were to, if we wanted to find the critical value, well, never mind. We're trying to find the p-value. So we're only interested in just this one tail, and the p-value is going to be the same thing as the area to the right of that. Okay, so area is also probability, so we're going to use the t dot dist. Okay, remember the dist functions give you probabilities. Okay, so we know this much so far. So it's going to be t dot dist. Okay, and that x is going to be the actual t statistic that we got. So we'll put that there. Degrees of freedom. Now I calculated it here on the spreadsheet, but you should know that that's just the sum of the sample sizes minus 2. So n1 plus n2 minus 2. Okay, so it seems to be 114. I'll just put that there. and this is always going to be true. Okay, now this is not going to be correct because remember that Excel accumulates area from the left. So this is the amount of area to the left of this 4.13. So we found this area. So we need to do 1 minus this. Okay, so 1 minus that. Okay, and so we see that it's a very, very small value because that's a very large test statistic. And if you look down, you'll see that this is the same as the value that's down here. So it's called right P. But these two numbers are the same. I just wanted to show you step by step how you go about finding that. But so this P value then is, since we only want 3 decimal places and we don't even get a 3 until like 5 or 6 in, so it's just going to be 0.000. Okay, and that's just because of the rounding. Okay, so the correct conclusion then, so with a p-value that small, so alpha was given as 0.05, right? In the problem stem, it says that the alpha significance level of 0.05. So we are going to reject if there is a p-value that's less than 0.05, and this is definitely less than 0.05, so we're going to reject. And the reject means that there is sufficient evidence that the mean was significantly higher for the children who watched the food ads. So we'll reject that. Okay. All right. Now this problem here is asking you to find a confidence interval, and this was something that is in your book, and I'll just show you very quickly what the formula is. To find it, let me get it real quick. Okay, so the formula for that confidence interval is here. Okay, so basically it's going to be the difference between the two means minus a little bit and plus a little bit. So let me show you where that is on this spreadsheet. So I gave you a spreadsheet that will calculate this for you. And once again, it's just a straightforward plugging values into this formula here. But over here on the right of the spreadsheet, so I've calculated the difference here. So this right here is going to be where you where that confidence interval is calculated. Okay, so you start off by having that center value here, this difference between the two means. So x bar 1 minus x bar 2, and that's what this is here. Okay, so that's just this minus this, so 27.4 minus 21.1, and that's the difference right there. So that's going to be the middle value. So we know that the confidence interval for how large this difference is going to be something a little bit less than this, and it's going to be somewhere between something less than this and something more than this. Okay, so what I do here is I'm starting off with this value here, so this is E10, and then I'm subtracting a certain quantity, and this quantity is it's going to be the alpha level times the square root of something involving the pooled variance and then this sum right here. Okay, and if you take a look at this, so this part's straightforward. So this square root of the pooled variance plus this. Okay, so that part is just right here. Okay, now this t alpha over 2, that's your critical value, your two-tail critical value. Okay, so in order to find that, we need to actually use the t inverse function. Okay, so that's calculated here in cell E13. Okay, so I'm taking this, so calling T inverse, remember T inverse gives you critical values, and then I'm cutting the given alpha in half, right? So the given alpha, stated alpha for my version of the problem is 0.05, and I cut that in half, and then I put in the degrees of freedom, okay? So remember that these functions accumulate from the left, and they give you the critical value on the left. So that is going to be the left critical value, and so the right one is just going to be the positive version of that. So in this cell, I'm just multiplying by -1 to flip the sign. Okay, so that's where the T alpha over 2 part of this comes into play. Okay, so if I look at this, I'm taking that contents of E14, which is there, and multiplying it by this, okay? And so that's where I got that lower level, okay? So what this is saying is the actual difference between these two populations is somewhere between 3.28 and 9.32, and I am 95% confident that it is in that area somewhere, okay? So this is the middle. It could be anywhere from here to here, okay? So let's put those in and see if those are right. All right. Okay, so 2 decimal places, 3.28 and 9.32. Okay. All right, so that's number 5 there. Okay, so that sheet should help you a lot, but I did want you to be careful and make sure that you know whether you're dealing with one-tailed test versus two-tailed tests. Okay, so let's go on to question number 7 then. So this is now doing a different kind of t-test. This is doing a paired samples, okay? So what this means is that we have data that lines up so that each row, the observations across each row are matched up with each other, okay? So in this particular case, we have, I'm gonna go ahead and just click here to get the data. Then I'll click here to open it in Excel. Okay, so this is an example of when we would use a paired sample test. Okay, so notice that we have a number of different products here. I guess this is like 10 different products, and it was purchased in a warehouse club, and then it was purchased in a store, I guess. So 2 different purchase locations. So we had 2 different prices. But notice that it doesn't make any sense to treat these as independent samples, because these are paired, such that these are prices for a particular product. And it wouldn't make any sense to compare the mean of this and the mean of this, right? So what we want to do is figure out, well, is there a difference, across each row? Okay, and I show in another video how to do an independent paired samples t-test manually, but for this problem, I'm going to go ahead and do it with the Excel tools. Okay, so let's go ahead and run the test, and then we'll back up and take a look at the hypotheses. Okay, so I'll come here, and this time I'll go to Data Analysis and t-test paired to sample for means. Okay, now for the other one, we could have done this t-test to sample assuming equal variances. That's our independent samples t-test. But here we're doing t-test paired for to sample means. Okay, and I'm going to go ahead and select the warehouse club as the first variable range, and I'll select the store brand for the second variable range, and this defaults to 0, so my initial hypothesis is that there's no difference. I need to have this label selected to let Excel know that I selected the first cell that I selected in each range is a string, that is the name of the variable. And the alpha here is going to be given to me in the problem. So let me go back and double check. So this says at the 0.01 level of significance. So I need to change this to 0.01. Okay, so that's my alpha, and I will put the output of this right here. That's good enough, and select OK. All right, so there's my, let me move it over a little bit. I'll just put it over here. Okay, so this is the output of Excel's paired sample t-test. Let's just wipe out a few of these decimal places here. Okay, we might need a few more decimal places. Okay. All right, so all right, now that we've run the test, we need to go back and see what is it this output is telling us. So let's go through these questions step by step. So we're letting mu1 be the mean prices at the warehouse club. Okay, so this is this average, right? Okay, and mu2 be the mean prices for the store brands. Okay, that's there. State the null and alternative hypotheses. Okay, and we want, once again, we have to investigate what are our okay, so just to identify where we are, we're going to do the same sort of drawing thing here. We've got, once again, we've got two different samples, and we just need to keep track of which is which. So we'll say, okay, average one, this will be the warehouse. So we'll, yeah, it's kind of hard to write with this. Okay, but that says warehouse. And then the average 2 is going to be for the store, or store brands or whatever. Okay, just to keep those straight. Okay, so this is asking us, is there evidence that the mean price of the warehouse club purchases is greater than the store brand purchases? So we'll say, okay, so we're looking at an alternative hypothesis, which is the thing we're really interested in establishing. So we're saying, well, is it true that mean 1 is greater than mean 2? Mean 2, okay, which makes our null hypothesis the opposite of that, which would be that mu1 is less than or equal to mu2. Okay, so now I'm just going to do a little bit of algebra to transform these things. So we'll say, okay, so this is really the same as mu1 minus mu2 is less than or equal to 0, which mu1 minus mu2 can be abbreviated mu sub d. Okay, it's less than or equal to 0. All right, and over here, same thing, mu1 minus mu2 is greater than 0, making mu d greater than 0. Okay, sorry if that's difficult to read, but it's kind of hard to draw on the screen. Okay, so now we've got our hypotheses. So let's see, which ones were they? This one, so A. Okay. Okay, so now the critical values. So we are asking, notice that our null hypothesis has to do with the direction. So we have we're only interested in rejection region on one side, particularly on the right. Okay, so the idea is that if we get something far enough out here, we can definitely reject the idea that it's less than or equal to 0. Okay, let's say this is 0. Okay, so if it's out here, if it's sufficiently far out here to the right, then we can reject this null. Okay, so we have a one-tailed test with a rejection region right here. Okay, so we're only going to have one critical value, so we know that much. Okay, and so let's see how we can if we can read it off of this. Okay, all right, so there's my the output from the paired samples t-test, and I have here something called t-critical one-tail. Okay, so this is the critical value for a t-test with a right tail rejection region. Okay, now let's say my null hypothesis was that this mu sub d is greater than or equal to 0. So I would have a rejection region on the left. In that case, the critical value that I would be interested in would be on the left, which would just be the negative version of this. Okay, so but since I'm only interested in the one-tailed critical value on the right, I'm doing the positive one. So 2.8214. So 2.8214. I hope I typed that right. Okay. Okay. So now what is the t statistic? Okay. So we're doing the critical value method here. So we're going to keep an eye on whether this t statistic is greater than this. Okay. So coming back to this, we see if we have, good heavens, if we have anything larger than 2.82, so we'll say this is 2.82 right here. Anything larger than this, we're gonna go ahead and reject. So that's what we're keeping an eye on here. So what was our t statistic? It's here, 0.2137. 0.2137. Okay, 2 decimal places, so 0.21. Okay. All right, now notice that this t statistic is not greater than this, so we're going to fail to reject. So we're going to do not reject the null hypothesis and say that there's not sufficient evidence to conclude that alternative that we were interested in. Okay. All right. Now, so these are things I didn't really hit very hard, but you should know that we're making a hypothesis about the difference, the differences between these means, and in order for our statistics to be valid, we have to assume that those differences are approximately normally distributed. And I didn't really hit that very hard because it's usually a fairly safe assumption. Okay, and so find the p-value. So once again, we can get our p-value over here from this output that Excel gave us. Now remember that we are doing a one-tail test. So notice that this says this is a p for one-tail p, that the t statistic is less than or equal to a certain value. So this is one tail. So this will be our the p-value that we're interested in if we're, because in our particular case, we're doing a one-tailed test. But we can see that we're also given a p-value for a two-tailed test, but we're only interested in this case right here. Okay, and you'll notice that for a 0.05 level of significance, to have a p-value that large, we can see once again we're going to fail to reject. Okay, okay. All right. So the meaning of this p-value, so again, this is just the definition of the p-value. So this is the probability of getting a test statistic at least as extreme as the one that we got. Okay. So the probability of obtaining a sample mean difference less extreme. No, the probability of obtaining a sample mean difference at least as extreme as this one, if the population mean prices are the same. Okay, so if in fact those prices were the same, then the probability of getting this p-value is pretty high, and that's why we can't really conclude that there's any difference between the two. Okay. Okay, so number 8 does the same thing, and I hope that helps. Good luck.